Hello friends, today we study about resistance and resistivity, its explanations. First we take resistance. Resistance is the property of a material which oppose and restrict the flow of current on them. That is the resistance units is ohm. Symbolize this type. Resistance also depend on conductor length, directly proportional to its length, inversely proportional to its cross sectional area. So R is equal to rho L oblique A, where rho is a specific resistance or resistivity of material of a material. Its units is ohm meter. So rho is a specific resistance. It is constant. Now we take resistance is also depend on nature of materials, its purities, hardness, temperatures of materials. Then we same is resistivity accordingly resistivity be depends. Now we take unit group. There is a unit group which each side equal 1 meter, 1 centimeter. So in that case rho is equal to RA oblique L, and rho means resistivity is equal to ohm A is equal to 1 and L is equal to also 1, that is rho is equal to R. So we say that in unit groups is its each other sides in front in between resistance is called specific resistance of that material, resistivity of that material. Now we take some conductors in different size, such as cross sectional area, such as small cross sectional area, large length, that is smaller L, large A, and in this case large L, smaller A. In both cases resistance which conductor is more, so that is the more resistance, because R is equal to rho L oblique A. So R is more in this case, and in this case A is also larger inversely or smaller, R is low. So accordingly, where cross section area increases, resistance decreases. So we take now we discuss about conducting materials, heating materials, semiconducting material, insulating material, its resistivity. So conducting materials, silver, copper, aluminum, mostly copper and aluminum is used, which resistivity 1.6, silver resistivity 1.6 for 10 to the power minus 8 ohm meter, copper 1.7 to 10 to the power minus 8 ohm meter, aluminum 2.8 into 10 to the power minus 8 ohm meters at the 20 degrees Celsius. So we mostly copper and aluminum is used for conducting material in wires. Now in heating material, that is the appliances heating elements and furnace heating elements, there is a rheostat. So it is used nichrome, constantants, manganese, which resistivity is high resistivity materials. Resistivity is high, rho is high. In this case rho is high. And semiconducting material is mostly used in electronics, and its resistivity more than conducting material, less than insulating material. Germanium, silicones, and insulating material is mostly its resistivity very high, and there is no flow of currents in insulating materials. Its resistivity is glass, mica, rubber, all are insulating material or which resistivity is too much, very more. Hence, there is no flow of current in this. So, accordingly, in design, which material selections is resistivity and resistance study is very helpful. Now, the temperature measure role in dependence of resistance and resistivity. Accordingly, resistance increases. The formula RT is equal to R01 plus alpha T, where alpha is temperature coefficient of resistance. And there is a 0 degrees Celsius resistance, there is T degrees Celsius resistance. Solving this alpha, temperature coefficient of resistance is equal to change in resistance oblique R0 T. So temperature coefficients of resistance say that there is change in resistance per ohm per degree change in temperature is called the temperature coefficient of resistance, and is temperature coefficients of resistance is very low for heating elements, and its property is also useful for selections of materials. Now we take superconductivity. There are some metals and chemical compounds which resistivity becomes zero when their temperature is brought near to 0 Kelvin, that is minus 273 degrees Celsius. At this stage, material attains superconductivity, and that is said that which resistance become zero, and there is no losses in conductors. So, it's a superconductivity definition.